Okay, the directions say find the mean, median, and mode for each set of data. Now, you could just do this by hand. To find the mean, don't you just add up all the numbers and divide by how many there are? So you would need to add up all of first period's numbers, divide by 17, because there's 17 of them, and that would give you the mean for first period. And then you would do the same thing for third period. But then to find the median, are you going to have to take all of those numbers and list them in order? So that's probably a little more time consuming than doing it in the calculator. So let's review how to do this in the calculator. Tell me what you press first. Right, stat. Then what do you press? Edit. Then what do you do? Right, I'll take first period's data and put it in for L1, and I'll take third period's data and put it in L2. Once the data is in, what do we press? Stat again, and then calc, and then one variable, which is number 1. Now, beside the word list, if you're trying to find first period's data, it should say L1. If it doesn't, how do you change it to L1? Second, and then 1, right? And then you go down and you hit calculate. What is the mean for first period? That's right, 68.9. Okay, what is the median? Right. And then the calculator does not give you the mode. You have to do that on your own. So what did you get? 64, 68, 76, and 88. Okay, so there were 4 numbers that occurred twice in the data, and they are all the mode because the rest of the numbers in the data only occur once. All right, now for third period, to find their mean, median, and mode, you go back to your calculator and you hit stat again and calc again and one variable again, but this time the list should say what beside it? L2. And to get L2, it's down there above the 2 button in blue, so we have to hit second first and then the 2, and then calculate. What is the mean? 72.9. What is the median? And then what is the mode? 44, 60, 92. That's what you said? Okay, because all of those occur 3 times. You got 3 44s. You got 3 60s. Oops, I kind of missed that last one. And then 3 92s. And no other numbers occur 3 times except for those 3, so those are your modes. Okay, any questions about that? All right, now they want us to explain what these measurements tell us about each period and how they did on the test. Well, I'm just going to sum it up by saying third period did better. Because they had a higher average and median, which means the middle of their data and everything above it was greater than first period. Now, can anybody look at the data and tell me what you think hurt first period? Right, look at this 24 and 28. Did anybody in third period make that low? No. Okay, so that's what hurt it, was them. They skewed the data to the left. It would look like this if you graphed it. It would be like skewed to the left. Most of the data's over here on the right, but those outliers bring it down on the left, and that's what pulled down their average. Earlier in another class, I calculated, y'all pay attention. In another class, I took out these 2 from the data and recalculated the mean, and the mean actually jumped up higher than third periods. Okay? So, right, but then when I took out their lowest 2, they jumped up higher again. Okay? But not as, they didn't, like, when I calculated first periods without their 2 outliers, they jumped up to like a 74 point something. But then when I took out third period's two low scores, they jumped up to a 76. So 74 and 76 were a little closer than 68 and 72.9. All right, now we're going to keep working on dimensional analysis. So get out your packets and turn to page, I can't remember how far we got yesterday in this class. On page 16, did we do all of those? I don't think we did. We didn't do 4 or 5? Okay. All right, so let's go to page 16 and look down at 4 and 5. Next period, we'll practice this stuff, but more of a game mode where you can earn candy. So that means you need to pay attention now so the next period you're able to do it. You can go back there. Can you get behind me? Yeah, it's just right back there. All right, number 4. Did it sharpen it? Okay. Okay, number 4. 1 milliliter of ink can print 50 pages of text. If you had 100 gallons of ink, then how many pages could you print? Okay, so here's the scenario. We've got 100 gallons of ink, and we want to see how many pages we can print, and we know that 1 milliliter of ink can print 50 pages at a time. Okay, so 1 milliliter of ink will print out 50 pages, but we have 100 gallons. Well, don't we kind of need to know how many milliliters of ink we have, since this is given to us in milliliters? Okay, so what do we start our conversion chain with? 100 gallons, though, because that's how much we have. Right? Right. Since we're in gallons, we now use the info that the question gave us. 1 gallon equals 3.79 liters. Remember, if you just want to watch while I explain it, you can, and I'll give you time to copy. Now, liters is in the top, so we put liters in the bottom. And we're trying to get to milliliters, though. So at this point, we need to convert milliliters, or liters to milliliters, sorry. So you can either use King Henry died by drinking chocolate milk, or there may be a conversion at the front of your packets. Let's see. 1 liter equals 1,000 milliliters, right? So yes, like Angel said, you can use that. 1 liter is the same thing as 1,000 milliliters. Right, because you would have just moved the decimal point 3 units to the right, and that would have added 3 zeros. Now that we have changed it over to milliliters, now I'm able to use this 1 milliliter of ink is able to print 50 pages of text. Okay, and isn't that our whole goal, to figure out how many pages we can print? So that means we're done with our chain, because we've made it to the units that we want our answer to be in, pages. We cross out all the other units, that's why you have them top and bottom. Now the bottom is just 1 times 1 times 1, so that's not going to do anything. So all we need to do is multiply those numerators. And what do you get? Can anybody say it the right way? Okay, first write out the digits. Right, y'all are right. 18,950,000 pages. I heard you. That's how many pages you would be able to print if you had 100 gallons of ink. Yeah, it is. That's for like a company. All right, number 5. A clerk can, this should really say file. A clerk can file 375 sheets per hour. If there are 225 sheets in an inch, what they mean by that is if you've got like a stack of paper and it stacks up to an inch tall, there's 225 sheets in that stack. How long will it take her to file 125 inches of loose sheets? Okay, well, what do we start with? What is the question asking us? Right. How long will it take her to file 125 inches? So that's what we start our conversion chain with. Now, this is why knowing how to do the conversion chain is so helpful, because now whatever is on top goes on bottom. And what do they tell us about inches in the problem? What's it say? Right, every inch is 225 sheets of paper. Now that we have sheets on top, we put sheets on bottom, and what do they tell us about sheets? Right. Okay, now, remember, the question is asking how long. So don't you think they want our answer in hours? Because how long would be a time frame? So that means hours is what we needed to make it to, and we did. We crossed out the others. Now, since we don't have just ones on the bottom, we are going to have to divide, so let's simplify first. 125 times 225 is what? Right. And then on the bottom, you'll just have 375. And then when you divide those, what do you get? 75 what? Hours is how long it would take her to file that many inches of loose sheets. Because think about it, that's inches. There's 225 sheets in each of those inches, right? So 125 times 225 is what, that means there's 28,125 sheets of paper that she's got to file away, and she can do that many sheets per hour. So you divide how many total sheets she's got to file by how many she can do per hour, and that's how long it will take her. That's not a good job to have. That'd be boring. All right, now turn to the next page. All right, we are going to just skip number 6 for right now. We are coming back to it, though. Okay, but it's just a little more involved than the rest of these, so I want to save it for last once we're really good at these. All right, so let's go down. Did we do number 7? No. We didn't do number 7, though, together? Okay. You want to try it by yourself? Okay, go ahead. Try and go over it. You start with 180 days, so that means days has to go in the bottom. We know that every day has 24 hours. And now that we're in hours, we know every hour has 60 minutes. And that's where we can stop our chain, because our goal was to make it to minutes, and we have made it to minutes. We cross out days with days, hours with hours. The denominators are just both 1, so you're not going to have to divide. So your final answer will just be 180 times 24 times 60, which is... Right. So if you didn't get it right the first time you tried it, do you see now what you did wrong? What'd you do? Change it to second? Okay. All right, now we already did number 8 yesterday, so as soon as everybody's finished copying number 7, we're going to go down to number 1, going on a cruise. Okay, everybody ready? All right, going on a cruise. Your cruise ship is leaving for a 610 league adventure. How many nautical miles is this if 1 league equals 5,280 yards and 1 nautical mile equals 6,076 feet? All right, question number 1. What do we start our conversion chain with? 610 leagues, because that's how long the trip is. Now, since we're in leagues on the top, you've got to put leagues on bottom. Now, what's something else you know about leagues? Correct. Okay, but now remember, our goal is to get to what unit? Nautical miles. Okay, well, we know that 1 nautical mile is that many feet, but we're currently in yards, so what do we need to do? Right, we need to take yards to feet, and 1 yard is equal to 3 feet. And now that we've done that, we have feet in the top, so now we're able to use this information about 6,076 feet is 1 nautical mile. Okay, so now we've made it to the units that they want the answer in, which is nautical miles. All the other units cancel each other out. And now the top, you would multiply 610 times 5,280 times 3 times 1, and it becomes what? So 9,662,400. Okay, and that is leagues converted over to, well, nautical miles, but you're not finished till you divide by this. And what do you get? Right. Right. Y'all are both right. 1,590.3 nautical miles is how long the trip will be. Okay, now I want you to copy that, and then I'm going to leave it up there so you can reference it. I want you to try number 2 by yourself.